We continue with some more problems in section 9b related to linear modeling. Now you've seen probably in algebra that given certain information about a straight line, we can set up the equation of the straight line. And that's exactly what we're going to do here. So look at problem part A. A machine is purchased for $15,500. Its value after 5 years is $8,000. So its value decreases as time increases. So what are the two variables here? We have the value and we have time. So this is value depends on time. So time is the independent variable and value depends on it. So it's the dependent variable. So find the linear equation that models this particular relationship between value and time. So in order to write down the equation, remember that this is the equation, y equals mx plus b. We know what the initial value of this particular machine is. So it's 15,500. So that's the initial value of the machine, 15,500. All we need to know is the rate of change of value with time. So the minute I say rate, it's the same as slope. The change in dependent variable over change in independent variable. So let's see how the value of the machine has changed over 5 years, and that'll give us the rate. So this is the change in the value, so the change in the y coordinate. It's 8,000, which is the value after 5 years, minus the initial value, which is 15,500, divided by 5. When we simplify it, we get negative $1,500 per year. So the negative should be obvious because the value has decreased. So the final value is smaller than the initial value. So the change in the value will be negative. And that's the reason why our rate is negative. So the value of the machine decreases at the rate of $1,500 per year. So I use the word decrease in the place of negative, and it's still correct. So this is the rate. The signs are very important to set up the right model. So now we have everything we need in order to set up the model. Dependent variable y is equal to the initial value, 15,500. The rate is negative, so that's negative $1,500 times x. So this is the model. A model is nothing but an equation. In algebra, we use x's and y's. Since algebra is being applied to the real world, we just use the actual words. Value is equal to 15,500 minus 1,500 times the time in years, which is just like y equals b plus, and in this case, m is negative, so it is b minus, basically it's b plus slope times x. The slope happens to be negative in this case. Here's another situation. The campus Democrats plan to pay a visitor $100 to speak at a fundraiser. Tickets will be sold at $4 a piece. So $4 per one ticket. So the amount of money that they're going to make, their revenue, depends on the number of tickets sold. So that is the relationship. The number of tickets sold is the independent variable, and profit is the dependent variable because y depends on x. So the dependent variable is the profit, and the independent variable is the number of tickets sold. So rate is $4 per ticket. Profit is revenue minus cost. Profit is equal to 4 times the number of tickets sold. I'm just going to call it N, minus the cost would just be paying the speaker, which is $100. So P equals 4N minus 100. If we sell 10 tickets, for example, then the profit P is equal to, using this model, 4 times 10 minus 100, which is negative 60. So if only 10 tickets are sold, they're going to lose, that's a loss of $60. Now, in order to break even, the revenue would have to be equal to cost. We need to make sure that the revenue is equal to cost. So that would cover the cost of $100 for the speaker. So, which means the profit is equal to 0. You can either set up R equals C or set up P equals 0. Either way, you get the same equation. So P equals 4N minus 100. We make the profit equals 0, which means we break even. So 4N minus 100 is equal to 0. We need to solve for N because we're trying to figure out the number of tickets. So add 100 on both sides first. So you get 4N equals 100, which is the same as revenue equals cost. Now divide both sides by 4 to get rid of this 4. So when we divide, we get 100 over 4, which is 25. So in order to break even, just to make sure that they are able to cover at least the cost of this event, they need to sell 25 tickets. If they sell anything more than 25 tickets, they make a profit. Example here, very similar to the previous two. You can purchase a motorcycle for $6,500, or you have the option of leasing it for a down payment of $200 plus an additional $150 per month. Find a function that describes how the cost of the lease depends on time. So clearly, the cost of the lease will depend on time. The longer you lease it for, the higher would be the bill that you would have to pay. So first of all, let's find the function. The rate is $150 per month. The initial value of the down payment is $200. Y equals mx plus b. Dependent variable is equal to the initial value plus the rate times the independent variable. So number of months is the independent variable. Cost of the lease depends on the number of months. So we plug in C for cost. Since this is just a model, we don't need to find out any specific values. We're going to call the number of months equal to N. So C, the cost, is equal to $200 plus 150 times N. So find N for C is equal to $6,500. So plugging in the numbers. So what are we trying to do here? We're trying to answer the second part of the question. How long can we lease it for before you've paid more than its purchase price, which is $6,500? So $6,500 is the purchase price, and we are trying to figure out how many months we can lease it for the $6,500. So plug in all the numbers. Basically, we need to solve for N, subtract 200 on both sides first. That'll leave us with 150 N equals 6,300. How do we get rid of the 150? It's multiplied to N. The only thing we can do is divide both sides by 150, which cancels off the 150 and gives us N equals, and that's an N, equals 6,300 over 150, which is equal to 42. So for 42 months, if we lease it for 42 months, we're paying $6,500. And if we lease it for more months than 42 months, then it would have probably been better to just purchase the motorcycle. Another example here. So a mining company can extract 2,000 tons of gold ore in one day, and that is going to give us only 3 ounces of pure gold um, per ton. So for every ton extracted, only 3 ounces of gold, we are able to extract 2,000 tons. The cost of extraction obviously has to be taken into consideration, and that is $1,000 per ton. So let's say P is the price of gold in dollars. So P dollars per ounce is the price of gold in dollars per ounce. Find the function that gives the daily profit. We're trying to figure out the profit of the mine as it varies with the price of gold. What is the minimum price of gold that would make the mine profitable? So first of all, we need to set up the profit equation. Profit is revenue minus cost. So what is the revenue? Revenue is excluding the cost of running it. So let's just do the simple calculation. For 1 ounce, it's P dollars. For 1 ton, 3 ounces of gold can be extracted. So if you take out 1 ton of ore, we get only 3 ounces of gold. So if the price per ounce is P dollars, then for 3 ounces, it would be 3 times P dollars. So that would be the revenue for 1 ton. But in a day, we're going to extract 2,000 tons of ore. So 2,000 times 3 times P would be the revenue for that entire day in this particular mine. So for 1 ton, it's 3P dollars. For 2,000 tons, it's just 2,000 times 3P dollars. So that is our revenue. 2,000 times 3P is equal to 6,000P, so that's revenue. Minus cost is $1,000 per 1 ton. But we're going to extract 2,000 tons, so it's 1,000 times 2,000, which is $2 million per day. So to break even, the profit would have to be equal to 0, which is the same as saying revenue would have to equal cost. So let's see how that works. Revenue is 6,000P would have to be equal to the cost, which is $2 million. When we solve for P by dividing both sides with 6,000, P, the price of gold per ounce, is $333.33. So the price of gold would have to be greater than 333.33 to make the mine profitable.